Hello there, welcome to this Shieldia guide on how to use the Tartarus lab for the damn vulnerable web application Recon on Low Security Purple Team Edition. We'll think of a better name at some point. But in this video, I'm going to demonstrate how we can use Nuclei and my Omega CLI to automatically hack the damn vulnerable web app. So we're going to write a template file, or I'll show you how I would write a template file. And then later on, I'm going to demonstrate how we can use the Omega CLI to automatically run the adversary emulation activity and then also get the alerts from the seam in one file swoop, as opposed to we'll do some hacking activity, we'll try to see if it's going to be replicated within the seam, and then look at that if it's actually in the seam. Instead, oh no, contraire monsieur, we'll do it in one pipeline all at the same time, so that we can ensure these things can then be placed into something like a CI/CD pipeline. So when you're writing your rule logic or you're editing your rule logic, it would be trivial to test these things against live sources in a live environment if you actually want to do test-driven development in a test-driven detection in a meaningful way, as opposed to just I felt like it, I just felt like it. We don't want that. We want actual data and statistics to back up our findings. And a new feature, I'm on the side of the screen, and I'm on the side of the screen. I have learned from last time that being on the side of the screen will block pretty much all the important information in the Elastic seam. So instead, I can now just switch and go back and forth. Head up the blog, shieldia.co. We're then going to go through this blog post. You're going to need the prerequisites if you want to follow along at home to a larger extent. You'll need the blue team setup. That will bring up the entire enterprise network for you. So a firewall, the seam, the damn vulnerable web application, and a Kali instance, so that everything is as modular and then as easy to integrate and use as possible for you at home. So why did I decide on the purple team as well? Primarily because of length. I had experimented with 20,000 word blog posts. That's not really a sustainable method to go in. Instead, trying to keep the posts about 5,000 words and then introduce something new in each of them, or clarify some aspects of what we're working on in them. So today we're going to be introducing Nuclei, a very powerful templating engine for interacting with websites, so that you can do vulnerability assessments in an extremely granular and modular way. If you want to just use all of the defaults, you can. However, I would be a bit wary, as we'll discuss later, why just using the defaults is probably not going to be applicable to your environment. I would also highly recommend looking at the documentation for the template files. I found a lot of use in trying to understand, because there are some template files for the damn vulnerable web application, but they aren't, that are in the templates GitHub repository, but they aren't actually effective in the way that they should be. I will demonstrate that as well. So definitely read the documentation, all of the different protocols. Well, primarily we're going to be using headless HTTP and then the flow protocols. And then the reference, the extractors, the matches, the variables, all that, well worth a read. To one of the rules that we have within Sigma, so this is another project. In Sigma, we have this specific rule to catch bad user agents within the Apache weblogs. So I've taken this rule from the Sigma HQ GitHub project, and then made some modifications for newer and different user agent strings that we want to look for. So nmap, false full. And all of this is couched with the understanding that when we discussed changing the user agents, these things are trivial to change because it's in the attacker's control. This is merely to demonstrate the functionality and how the functionality of the Omega CLI, of Nuclei, and how we can use these things and how you can use Sigma, so that you can write reusable detection logic for essentially any seam. So you write once and then you can use them everywhere. If you want to move over from Elastic to a different seam provider, Sigma gives you that freedom to be able to do that, because you can just rewrite your own rules. Sigma, I've written my own template file, not template file, sorry, the entire processing pipeline for a new backend. It is a lot of work, but if you've got a brand new seam system that isn't integrated in Sigma, you can then write a backend pipeline to be able to convert these rules into your specific seam use case. It's most certainly possible. This is not going to be a treatise on Sigma rules. That will come later. Instead, this is going to be a bit more of a treatise on the Nuclei templates and how you can write them. We have already do we have a flow HTTP? No, that's the other one. Do we have? Okay, well, we'll take one of the example templates from the Nuclei templates, and then I'll briefly discuss some of the issues that I don't need to dig on anyone that I found with this template, that then we can move over to actually making it more effective. And it's helped me in my understanding of Nuclei and how to use it, especially with the damn vulnerable web app. So this will scan for the default login. So this is all perfectly legitimate and perfectly fine, and this is how it should be done. But then it does some stuff where it's interfacing with the cookie session in a way that it really, it shouldn't. Because here it's setting some cookie variables, but these don't actually get set, at least in the current version of Nuclei, as set as you would expect them to be set. What you're going to want to do is install Nuclei onto the Kali instance, which I already have done. It's a simple sudo apt install Nuclei, and then that'll install it for you. Now you can view the help. Well, you can start it. This is going to download some packages and download the latest template files for the first time you run it. There's a DUC flag that you can pass so that it doesn't update these things every time. But we're not going to worry about that today. Instead, this is how the template files would be downloaded on first boot. And then it also checks every time you run Nuclei if there are any new templates. So if you notice any traffic for when you start it, that's what some of the traffic is for. As demonstrated with this template file, it'll do a scan and then be able to detect the damn vulnerable web application has a default login. However, the issue with it is that in Wireshark, if you look, this is what the cookie will be set to. So it's setting security equals low, but then it also has a holdover, security equals impossible. If it was doing more strict matching on the cookie values, it wouldn't work. It only works due to a sort of misconfiguration in how damn vulnerable web application is reading the cookies. It'll read from left to right, so it's going to see security low, that's what we'll pick, and not incorrectly pick the security impossible. So that's just something to note. So instead, I've written it to be slightly different. Now this example template doesn't use the login feature. This is more a generic, what I'm calling like a simulated template, so that we can use it to simulate the activity, but without actually interacting with a specific vulnerability, because this isn't testing for a vulnerability. It's testing for the default behavior that any web server would have. In this instance, it being a directory enumeration. So as stated here, these template files have it's a YAML, yet another markup language that has required fields, and then how we fill those fields out is up to us. So we'd have the ID field. So this is the name that will populate there when you run these things. There's the info, so it's metadata about the rule. We're saying the name of the rule, the author, severity, that sort of stuff. Tags, all that good stuff. Then this is a bit more custom. We're defining a variables section. In this more global variable section, we will then define an array of user agents. So these are known bad user agents that we want to test for. So this is the NS, the mmap, fuzzfosdefault, Hydra, SQL map, Durbuster, and then this one is actually also just the default user agent that Nuclei uses. It's, as stated here, it's the Nikto user agent. They made a commit to change it because people were just going, oh, we detected Nikto, that sort of stuff. So instead they've changed it to be a bit more generic. However, if you look at the build of this specific, because you're leaking a lot of stuff, this specific version of Chrome here, this is from like 2020. It's a 5-year-old user agent. If you haven't updated Chrome in 5 years, I mean, maybe you are the security vulnerability, but that's neither here nor there. Now, how we use that is we'll use the flow protocol. Again, consult the documentation for more details. We want to define a for loop to go over all of our user agents. So we say let user agent, an individual item, in iterate template, the user agents array, set user agent to user agent, and then we do HTTP 1. This HTTP can be any of the HTTP methods that you've defined throughout the rest of the template. So for each of the user agents in the array, do this one HTTP request. Cool. And then finally in this template file, we have the HTTP raw section. I use the raw as opposed to the HTTP, the other defined protocol within Nuclei, because for me it has just been a bit easier. We then define the get. So we're going to do like a browser would, get, and then the specific resource, and then the specific hypertext transfer protocol version you want to use. Then we define host, being this variable that has the host name. We don't need to worry about that too much. We'll do an accept, so accept any encoding type, and then user agent we are supplying, because again it's just a header field, we are supplying the user agent from this flow. So this user agent gets input here. So the first request will have that user agent, the second request will have that, etc., etc. Then we're going to say connection close, because the connection doesn't need to be open. So we just say connection close. We'll do a matcher, but we're not doing, this is an internal matcher. So it's not going to do like a matcher for each and every statement, because again, we're not finding a vulnerability. We're just simulating some malicious activity with this template file. Here we've explained that a bit. So now we can run this template. Because we're using Vagrant, we have a shared directory that can populate from the host system into the guest system very easily. In this instance, it's a mount point that mounts at the root. So if we do ls there, you'll notice something new here, which is the Vagrant directory. So we'll do an ls Vagrant. Now this has all of the stuff that's in the repository local to this system in the Tartarus repository. We can also then do like what's in the apps directory. These are all of the applications that you won't find in the GitHub repository, but then if you do run the Tartarus lab, they all get downloaded and then saved to your disk. Now we can look at specifically running the Nuclei template. So we have Nuclei installed. First of all, it doesn't come packaged by default. And then I'm going to do a Control-Shift-V with the with what I have in my clipboard. There we go. So here we're going to say Nuclei U specifies the URL or your target. It doesn't matter here that we're not specifying the subdirectory. Then we're going to use the T flag and specify which template file we want to use. So there you supply it with a file path and then a file name, the webhack tool user agent enum simulated. So it's a very creative name. We're going to run that and then, oh, it's already done. Let's have a look now within Elastic to see if we have that activity on file. So we can have a look in the Discover tab again. We're going to switch from metrics to logs. Thank you very much. We're going to say user agent dot original. So I know this is a good one to go for. Is, let's say, okay, fuzz to full is already, so we could say just fuzz, and then you can do a search like that. Boom, one request for fuzz. Similarly, so you can do these searches both in KQL or in Lucene if you select the specific search type. So KQL or Lucene. Lucene, you can do some other sort of searches. You can do a bit more fuzzy search, that sort of thing. But for now, we'll stick with KQL because it does also support the wildcard searching. So we're going to say, like, it's fuzz anything. We can say nmap anything, and then any of the specific user agents. So this isn't just like a wildcard for everything, although I believe it does support that as well. So that's just a wildcard over everything. Depending on your infrastructure, that search may not be ideal to run it over everything. So it's similar to how, for instance, in Splunk, you could just pop a search in and then it'll search through all of the records. It's a similar principle. However, we'll specify, because I know where this value is going to appear. It's going to appear in the user agent dot original key, and then the value we're going to specify to be something like nmap. So we can see here, yes. To look at the details, we can then move me over there. You can see here, you got these. If it starts with underscore, it's a metadata field added by Elasticsearch. The @timestamp field is when the event happened. Then there's some other metadata. We could see the remote IP address, so that's our Kali instance. We can see where the log data stream is. Then we can move or just search for user agent. Then it'll say, cool, that's the specific user agent that was used to access the web app. So that's all well and good. However, what if we could do this in an automated fashion? So that's where the Omega CLI would come in. We can further into the blog. This shows you how you can search for these things. I mean, you could also have done the search that I'm doing here, which is a source address search. Like, it's perfectly legitimate. Start address is 192.168.200. Then you can put this field. So anyone that doesn't have a user agent field, we're going to ignore. So we've added a filter for that the user agent has to exist, the field user agent. And then we can see here, these are the specific user agents that have attempted to contact from this IP address. We can then also confirm that by just opening the browser and then going to the damn vulnerable web app. So now let's have a look, inspect, and then we can on the network. So I'm going to do a reload quickly. Here we should see one of the headers being our user agent down here. So under the requests, user agent Mozilla 5.0, X11, Linux, etc., etc. So we could look out for that user agent now in the seam. Let us have a look. Hit it with a refresh, and there we are. So those are our browser requests to the damn vulnerable web app, captured successfully. Wait, too many hotkeys. There we go. Now, what if we wanted to do that automatically? We can with the Omega CLI. It is a means by which you can interact with a seam all via the CLI so that it can run adversarial emulation type activity safely, securely, easily. So we're going to do a git clone, and then there are quite a few prerequisites that I will go through now and install on my guest Kali instance to then be able to use this application. So I'll see you in a sec. Now that you've met all the prerequisites to use the Omega CLI, so clone it from GitLab. The reason I'm integrating with GitLab is so that it has better CI/CD automation pipelines than, in my opinion, than the ones available in GitHub, and I'm more familiar with it. In any case, you will be prompted by Python that you're in an externally managed environment if you try to do this within the Kali instance. Do not worry. This is the maintainers of Python in their infinite wisdom forcing people to use environment managers like Conda or venv. You don't need to worry about that. You can just delete the file. Jeff, the amazing, excellent Jeff Geerling, has a blog post on precisely that, which you can read and use that to delete those specific files. So once you've installed the Python requirements, it's not that heavy. You're going to then want to install docker.io. That is used to spin up the Docker containers. So we're gone from virtual machine, which is the big, heavy, lumbering, it's got an entire operating system on it. It's got a terminal window. It's got a display. It's got keyboard, all of that. Okay, huge, lumbering thing. We're going teeny tiny, just a little container. That's all we need now. It's just a little container. If you have the para virtualization set correctly, you should be able to do virtualization within your VM. It's not as efficient as doing it on bare metal. However, your virtual machine can then itself spin up virtual machines if you wanted, or in this case, Docker containers. They're not entirely analogous to virtual machines, but for all intents and purposes today, they are very similar. The Docker container just has packaged with it all of the required code to be able to execute a specific application. In this case, we want to execute Nuclei, Nmap, Netcat, and SSH. We're not going to be going through all of those today, but those are some of the features you can use. We're going to then say you need to add yourself, so your user, to the Vagrant user on the Kali instance to the Docker group so that it can spin up Docker containers, or else you'll get an API warning. That API warning has nothing to do with the API that we're interacting with via Elasticsearch. It is actually just an API warning you that you don't have the correct permissions to be able to use the Docker API. Then you can run a command like Python 3 omega pi tac h to get all of the help information in the right repository, in the right directory, sorry. So we can run that. These are all of the flags that you can use. So there's some propositional arguments, the Omega file, the specific backend connector that you're going to use. For now, only Elastic Local is supported. However, in the future, that's hopefully going to change. Help, print the help message, target is actually a required, it's a required argument. It's called optional here, but I didn't want it to be a positional argument. So you'd use the T or target flag. Local, you can tell Docker to inject the addresses that it's going to resolve to the local host address, as opposed to using the actual remote IP address. It is very useful for if you've spun up the Tartarus lab on your host system and you want to run these commands via the host system. If you're not going to be doing that, so you don't need to worry about it. The debug flag prints some of the useful debug messages. Config flag tells the script to use the .env file. So I'll do a cat env.example. So this is what your env file kind of would look like, minus all of the lines with octothorpes in them because it's not supported. And then it'll be the URL for your Elastic instance. It'll be the Kibana port, the Elasticsearch port. Then how you want to authenticate, you have two options. You could either authenticate via the API key, which is already provisioned for you. If we did a, how would we successfully do that? We could do a ls vagrant keys es API key. So that file does exist. That contains the super user API key that you can then use to inject here. The one printed to the screen, it's base 64. I'll give you a hint. Have fun. Then you have the Elastic. You could either do it via the API key or you could do it via the username. For the super user being Elastic and then the password. You also have to specify the cert file because everything has to be done via HTTPS. None of this HTTP unencrypted. That's not how we do it here. So you specify the cert file. It's to place it in the correct directory. It's as simple as cp vagrant cert root ca dot cert. You don't want to copy the key into the certs directory. I've already done this, so you can see here under certs there'll be the root ca cert, which is perfectly fine to put that places. The key you don't want to put it anywhere, but the cert itself is perfectly fine. Some more advanced options, you can set this to use SSH to be able to interact. So there's some templates that I've written that you need SSH for, namely the MITRE ATT&CK Atomic Red Team, the Atomic Red Team to run the MITRE ATT&CK TTPs on the target system. It does that via SSH. I couldn't think of another way to do that effectively. So it'll just SSH in, run the specific TCP test, and then exit that session. And then you could output the results to the terminal. Moving along, this has a similar templating structure to the Nuclei templates, but it's sort of a wrapper on top of running Nuclei templates. So here you could see name, some metadata, some info. This is more like a multi-line info as to, for instance, the directory enumeration test that we did, not that we did previously, that I can demonstrate at some point. It's a Nuclei template that runs similar to the previous simulated one where we simulate the user agent. It simulates a directory enumeration attempt. So it'll send 1,100 randomly generated directory names to the server, and then you'll get the results back from that. Why randomly generated as opposed to just a word list? If you're going to be using this to like train some models and stuff, because the word lists could be so different, you wouldn't want them to be in a specific order. You wouldn't want to just take the sec list's big word list and then use that, because that's going to train your models, sort of like AI models, incorrectly. So instead you could just use, granted using random names because it's just a random string of numbers does also inherently have some issues, but it's less so than using a predefined word list. Then you have some references, the date when it was created, and then there's, I believe, a modified flag. All of this stuff is through Cerberus it's a Python library that provides YAML templating checking. So all of these keys and values are checked to make sure that they are compliant with what the template should look like. Then you have references, so in your list. Then you have the executor. That's where all the action happens, is either executor or executors. Executor is one single runner. In this case, you define the name being Nuclei, and then Nuclei, you have to provide it a template file. Then this specific template file will get ran when you run this test. Similarly, rules, there's only one rule. You could run any number of executors, but there should only be one rule. So it's a many-to-one relationship or a one-to-one relationship, like in this instance. We define it that it's the seam rule new line delimited JSON as opposed to just placing it as Sigma. I'm still working on having it so that it literally will do on the fly Sigma conversions to your specified connector. That's still in the works. So for now, you have to do that you have to compile the Sigma rules before you run the application. But don't even worry about that. You just specify the rules and then the .json file. So that's just explaining what I've just explained. Now we can run the command. In this instance, it is Python 3 omega pi config flag. So that's just saying read from the .m file. What test you want to run? So that's a required positional argument. Then the connector, again required positional argument. Then the target, a required but not positional. And then I'm going to say D for the debug. When you run this for the first time, there's going to be a delay. It's downloading the Docker container image to your local system. I have already run this, so it doesn't need to download the image. We can see here with the D flag, it'll also give you some useful output for how you could run these Docker containers. So it's Docker run, add host, and all that stuff. Then we specify to do the domain resolution because we're targeting via the domain name, and the Docker container doesn't have access to your etc hosts file because I just wouldn't want to give that level of access. Then you specify the volume that you want to share from the host to the Docker container so that you can then place the template files, because my template files are local to the system. They're not in the Nuclei template GitHub repository. Then finally, we specify the duck flag so that it doesn't check every time because of the way that the containers are set up. It will check every single time. That's a waste of time. Again, due to how the template file is set up, we then tell it what rule to check. It does, by default, it'll try and check that there is data for that specified rule 3 times. You can specify a larger count, and then it'll wait 15 seconds for the data that's on the server to be correctly ingested into the seam. Here we can see, yes, the test has been successful because this specific UUID for this test came back as green. So you can see how you tie in the rule to the test, and then you don't need to manually do these tests every time because that's just boring. So that's a brief introduction to Nuclei and then the Omega CLI. There are some more advanced things, like I was talking about the executors, where here you can specify, which kind of takes it beyond just running a Nuclei template. You can specify, hey, run this netcat command to listen on port 443, because that's probably the port that, well, that's the only port that has access to the firewalls within the Vagrant lab. Sorry, not the Tartarus lab. And your adversary is probably not going to be listening on port 9000 or whatever the defaults within Metasploit are. They're going to be using, they're going to try and blend in as much as possible. So it'll run that netcat command in one Docker container, and then it will run another Docker container for the template so that you can get a reverse shell. Just by way of illustration, I will run this. However, it's going to jump ahead a bit because it's going to need to download the netcat Docker container. So see you in a sec. So now the command is finished. The more advanced version of the Omega CLI, you can see it'll still do template checking. It'll run the first Docker container, which it executes in sequence how you've defined them in the template file. It'll then make sure that the target is up, printing out the debug information for the Nuclei template that's run, and then closing off the listening netcat Docker container. you can see here that it successfully caught the reverse shell. Then finally, it's checked in the seam for any rule firings, and it would have fired 4 times for this example. We can then have a look within the seam to, because these rules are live and would be alerting in any case. There's some more stuff we can do where we can set the specific hosts to not be alerted, so that in the seam it doesn't, because we're still seeding data into the seam, so we wouldn't want that to be misconstrued as actual legitimate malicious activity, just our own malicious activity. We can then have a look in the seam. We can then go down into the alerts tab and see, I'm going to log in again. Odd. Browser troubles. Here we can see the Linux process creation, and then it's going to be reverse shell. We can see that successfully, both via the CLI, tested these things, because it's using a specific endpoint that's the preview endpoint. It's not actually creating these alerts. These alerts are generated irrespective of the script, because I wanted to make it as effective as possible, so then you can later add, like I was saying, those exclusions so that it wouldn't be alerted on the specific host in the rule that would exist within the seam platform, but the rules that would run wouldn't have that exclusion, and then it would correctly fire for those specific hosts and those specific alerts. We can now take a look at, later on, I'm going to discuss more as to how you can investigate an alert like this. But for now, this is one of the visualization or the analyzer screens that you can use to more clearly look at the activity that has happened. You can then trace that back all the way to the process that spawned it, because we're using the event query language, the EQL, as opposed to using the ESQL, which you wouldn't have such a process tree with. Even though you can do the correlation rules, you just wouldn't get this process tree from that. So there we can see the specific alerts that would have fired. And then this is the other via Apache with this suspicious meta characters is another rule that I've written. These rules, they're very similar, but they look for different activity within the shell that would run them. Now, yeah, that's all for that section. As I've demonstrated, there are quite a lot of use cases for an application like this. You can then see what the output would have been. There are other scans that you could do, like an nmap scan, which isn't quite supported with Nuclei by default because of the nature of the firewall environment, and then the way that they've implemented their netcat stuff. We don't have to worry about that, but you can use something like nmap directly within a Docker container to run these tests. This, for instance, would test for the scanning activity. And that's all I wanted to say for today in regards to Nuclei and the Omega CLI, and how you might be able to use that within your environment to test rule and detection logic. At some point, hopefully soon, we will have the CI/CD version of it also available, so that it could plug in directly to a pipeline, and then you wouldn't have to run the actions manually. That is the hope. But that's all for today. Thank you for tuning in. I'll see you next time.